Hey everyone, and welcome. We're going to jump right in and pull back the curtain on 5G. We're going to uncover the hidden global rulebook that makes our super connected world not just possible, but works seamlessly for all of us. So think about it for a second. You see that little 5G icon on your phone every single day, but have you ever stopped to wonder who's actually calling the shots? Who gets to decide what 5G even means? Is it Apple? Is it Samsung? A government? The answer is probably not what you think.
And there you have it. The real, official, technical name for what you and I call 5G is IMT 2020. Yeah, it's not just some cool marketing term. It's a really detailed, globally agreed upon standard for what the future of mobile communication should look like.
So let's get into what this rulebook actually is. This is really important. It's not the work of one company trying to win the market. Nope. It's the result of a massive international team effort. The referee in this global game is the International Telecommunication Union, or the ITU for short. They're actually a part of the United Nations, and their whole job is to create these technical recommendations so that everyone plays by the same rules. They're the reason a phone you buy in Tokyo works perfectly when you land in Toronto. And this quote from one of their own documents just hits the nail on the head. For mobile tech to really take off, it needs two things. One, it has to work everywhere on the planet. And two, it has to be affordable. A single global standard is what makes both of those things happen. Now, IMT 2020 wasn't just about making your Netflix downloads faster. The ITU laid out three very different and honestly pretty ambitious missions for what this next generation of technology had to pull off. First up, we've got EMBB, or Enhanced Mobile Broadband. This is the one you already know and love, even if you didn't know its name. This is the raw horsepower upgrade, giving us those crazy fast speeds and the massive capacity our modern digital lives demand. So what does this mean for you, really? Well, it means streaming 4K video on the bus without a single stutter. It means augmented and virtual reality that feels totally immersive with no lag. And it means you can still get a fast, reliable connection even when you're in a packed stadium with thousands of other people. The second mission is where things start to feel like science fiction. It's called URLC. Ultra reliable and low latency communications. This is for the stuff where a dropped signal isn't just annoying, it could be catastrophic. We're talking about connections that have to be rock solid and almost instantaneous. I mean, just think about it. You want self-driving cars to be able to talk to each other with zero delay, right? Or imagine a surgeon in one country performing a delicate operation on a patient halfway across the world. You need a connection you can literally bet a life on. That's what URLC is all about. And the third mission is MMTC, or Massive Machine Type Communications. Notice the emphasis on massive. This one isn't about speed, it's all about scale. The goal here is to connect a mind-boggling number of devices, billions of tiny, low-power sensors and gadgets, all talking at once. This is the true backbone of the Internet of Things. It's what allows for smart cities where traffic lights and parking spots are all connected. It's smart farms with sensors in the soil. It's factories where every single machine is reporting its health in real time. It's a quiet revolution happening all around us. Okay, so the ITU sets these incredible, ambitious goals. But who actually builds the tech to make it all happen? Let's look at the engineering powerhouse that turns these big ideas into actual reality. That job falls to a group called the Third Generation Partnership Project, or 3GPP. Here's a good way to think about it. If the ITU is the architect who designs the amazing skyscraper, 3GPP is the team of brilliant engineers who figure out the steel, the concrete, and the wiring to make sure it actually stands up and doesn't fall over. So how'd they do it? Well, their strategy was pretty clever. It was a mix of evolution and revolution. On one hand, they took the 4G network we already have, LTE, and gave it a major upgrade. That's the evolution part. But they also built a completely new system from the ground up called New Radio, or NR, just to handle those big 5G missions. That's the revolution. This diagram is a great way to visualize it. Think of our road system. The upgraded 4G towers, these NGENBs, are like the main roads getting a major overhaul. But the brand new 5G towers, the GNBs, those are the new multi-lane superhighways, and they all connect seamlessly, letting your data find the fastest route. All right, we've covered the big picture. Now, just for a second, let's peek under the hood, because the microscopic engineering that makes all this work is, well, it's just incredible. So your phone doesn't just blast data into the air. It's way more organized, almost like a digital postal service. Your data gets passed down through these different layers. Some layers chop it into smaller, manageable packets. Other layers wrap it in security, and the final layer slaps on an address and schedules it for delivery. It's an amazingly efficient system. And get this, it's not just the data that's organized, it's time itself. The network literally slices every second into these microscopic little fragments, frames, subframes, and slots. The super precise schedule is the secret sauce that lets millions of devices talk at the same time without it all descending into chaos. Okay, I know, that was pretty deep in the weeds. So why does any of this matter? Why should you care about layers and milliseconds and all these acronyms? Let's zoom back out, because this is where all that technical detail unlocks a whole new world. This is why it matters, because this shared rulebook makes things like this possible. This is V2X, or Vehicle to Everything. The standard literally defines how cars can talk directly to each other, using that PC5 interface you see there. They don't even need to be in range of a cell tower. That's a foundation for safer roads and smarter cities, and it's all thanks to the standard. And it goes way, way beyond just cars. The IMT 2020 standard was designed from day one to transform entire industries, or verticals, as they're called. We're talking about private 5G networks for super secure factories, remote healthcare becoming commonplace, and giving our first responders communication networks that just work, no matter what. This is about rewiring society. So in the end, that massive, complex global document, IMT 2020, is so much more than a technical specification. It's a foundation, it's a common language that innovators all over the world can use to create the future. The rulebook has been written. The tools are on the table. The only question left is, what are we all going to build with it?